Okay, so we've started. Welcome to week 21 of the Tinkerbell contributors meeting. Thank you very much for adding your names to the attendee list. If you haven't and would like to do so, please add that in there. I will add the doc to the chat in a few seconds or so. I don't think there's any new names at the moment, so let's kind of kick things off. I have a couple of things that I've added to the agenda that I've been kind of tinkering with over the last couple of days. One of which is kind of an idea that kind of came from Avi. And it's the concept of effectively using a OCI compliant register, so a container image register, but pushing our raw disk images to it. And there are a number of benefits from doing this, things such as image mirroring, RBAC rules on disks, and post-push webhooks, which will lead on to my next point. So what I've effectively done is I have used a tool that comes from a project called ORAS, which is OCI registry as storage. They have their own CLI tool, but they also have a Go package that you can import as well. So the demo is in two parts. One is using the ORAS tool to push images to a registry. And the second is an action which supports the capability of retrieving those artifacts that live within an image registry and then pushing that through a compression reader so that we get the decompressed output that we can then stream to disk. So what's the workflow actually look like? Let me make this a lot bigger. So I'll make this even bigger actually. So the first thing I'm going to do is I am going to just quickly show. In here are a load of images that live within the web root directory that I normally use the image to disk action for. I'm not going to be doing that this time. What I'm going to do is I'm going to do a push. So if we look here, I'm using the ORAS CLI and I'm pushing to this registry, which is here. So I quickly set up Harbor, which is a pretty kind of feature-full open source OCI compliant registry. And I created a project called Test that has TinyCore in there and the thing that kind of other things that I was listening for testing. So I'm going to push an image that's called Debian, and I've given it the tag raw.gz. And this is the file that it's going to push. And it's using the insecure flag because I am terrible with certificates. So we do an ORAS push, and that has pushed that image up to my registry. If we look now, we can see we now have that Debian artifact now as part of that project. So we can then, let me delete my last workflow. And get the correct template, which is this one. So quickly, what does that look like? So here is the workflow. It is almost identical to the image to disk action, in that a lot of the code's kind of the same. The main component that's different is none of the HTTP stuff. It's effectively all of the ORAS package that takes care of basically being able to do the lookup and get me the right image, and then it will take care of streaming it to disk. It will also, the way that it works is that it uses the tag. There's probably a nicer way of doing this. This is my first attempt at it, but it uses the tag to work out the compression type. So if this was .xz or xz, then it would use that algorithm, or bzip2 or whatever. That would be how it works. So if I pop back here, and we will reset to Pixie. So here's my machine saying welcome to y'all. I've reset to Pixie, and it's now going to use that new action. And it will look in the way that these actions always do. So does anybody have any questions about that? So just why or anything like that? There's some chat going on.
Is there a content type field you could use?
So there's a bunch of stuff that we can do. So there's annotations, there's the media types, which we can all use to determine the sort of thing that we're pushing to a registry. As I mentioned, this is kind of my first attempt at doing it, so I was kind of half making it up on the spot. This is the second time I've ever actually used it, but it certainly can be improved upon. We can look at, actually, instead of having it look at the tag, we can put an annotation in there which describes the type of compression that's being used. But yeah, I mean, as I say, we can mature this as we go along. This is effectively like the first attempt at doing it. As you can see, there we go. It doesn't take really any longer than the image to disk. There is a little bit more back and forth in terms of JSON parsing and then eventually getting the right stream. But other than that, we have basically pulled an image and written that directly to disk. If we refresh in here, we can now see that there's been one pull of our Debian image, and that was the OCI to disk action, doing a pull and writing that to disk. So as I mentioned, this kind of gives us a bunch of cool functionality that we can kind of start to make use of. We can do, as mentioned, we can basically protect images. We can have RBAC. We can do image mirroring. We could look at edge cases where we can basically package up an image repository with all of the images that people would make use of. We can push images to a bunch of open source and upstream repositories that support this. So things like the Azure Container Registry, the Google Container Registry. I don't think Docker Hub supports this, unfortunately, so that one won't work. In terms of local registries, Harbor, obviously, the Docker registry, which is the bare bones one, that one also works. And then there's some additional things we can look at. So somebody mentioned Kraken. There's also Dragonfly, which allows us effectively to distribute these images across facilities. So in large data centers, you could basically load balance where all these images are being pulled from and things like that. So there's a lot of kind of cool functionality we get out of this effectively for free. And I know Avi's not on the call, but a big thanks to Avi for a lot of the code. He's very quiet about all of this, but like he is the mastermind behind a lot of this functionality. So are there any questions? Oh, sorry.
Yeah. Question, Dad. This is super cool. So you can layer just like you would, container images. Is that accurate?
That is not accurate, unfortunately. So yeah, this is slightly different. So an actual real container image is effectively a JSON manifest and then a bunch of tarballs. And effectively, the way that it works is when you do a Docker pull, you get the manifest, and that tells you where all of those tarballs are. And then using the correct file system, it will basically it will build a file system from all those tarballs and get you the final result. This is not that. This is effectively JSON pointing to a single lump of data. So you can't do a Docker pull on this because Docker won't understand what it is. It will get the manifest and then it will go, I don't know what this gzip raw archive is. That's why things like Claire won't work. It can't understand this artifact that lives in a registry. So we get some benefits, but not all benefits of being able to put things in a registry. It's basically just a lump that the registry knows about, but it can't understand.
Interesting. Okay, that's fair.
Cool.
Thanks.
No worries. Any other questions?
will a proposal be put forth for this?
Yes, can be.
Oh, awesome.
Yeah. Cool. So some of the other stuff that kind of came out of this, I kind of mentioned this online last night, and quite a lot of people kind of got a little bit excited about this, which I thought was kind of interesting. We've had people from Google who do a load of image signing stuff. So they are actually looking at how we can sign our disk images, which leads into kind of security for free. We basically will be able to say, I've lost my train of thought because I saw that message. I'll come back to Jacob's message in a second. We'll basically be able to give us a root of trust in terms of where images come from. So we, as Equinix Metal, will be able to sign our images, and only with that signature know that they should be deployed within Equinix Metal data centers and things like that. There is a point about Oros pushing artifacts with multiple files. I don't think that means multiple layers, though, in terms of the way that we're looking at things, because it Oros wouldn't know to gzip and put things together. Plus, this is basically a big binary blob, not a file system as it would understand it. But yeah.
Okay, I'll have to dig in, because I mean the wording maybe is confusing because it uses words like layers and whatnot.
Yeah, that is confusing between files and layers. Because if we were to do Docker pull, what we would actually get is we can basically bundle a load of files underneath an image name, but they're separate files. They won't be layered together into the final artifact. So the parser that would exist inside OCI to disk would keep getting would have a bunch of images in there, and it wouldn't really know what to do with them. We
yeah,
could
that's
have
fair.
Yeah, okay. I mean, we can look at, there is some stuff that we could do that it comes to mind, but it wouldn't be the same as the way that Docker works, basically, is kind of what I'm getting at.
Yeah, I mean, I definitely wouldn't want to do a Docker pull. So my train of thought went to like, oh, interesting. So we could package kernels with, root FSs, and we could share those right across layers or something like that, or images. You can say, oh, I have one Ubuntu base image and I've got all your kernels, and then you could save on disk space, because now you're just like putting them together, right? Based on tag names. But maybe that's not the available, but that was kind of my train of thought. I was like, ooh, maybe that's possible.
It would be possible to do things like having raw OS images and then perhaps file system tarballs. So you could basically have our Ubuntu 2004 and then layer on top the way that Docker does. So you could have a tarball which basically says Ubuntu update, at which point the first thing it does is to write the raw image to disk. The second is to overwrite, like it would do when you stack layers in Docker in that way. So it'd be a combination of the two, and that would be supported in an OCI registry.
Okay, that's pretty cool.
The second thing, so I mentioned quite a few people seemed quite interested on social media. A lot of people kind of pointed out like, oh, you could do image scanning, to which I was like, no, because an image scanner would be expecting to build a file system from a bunch of tarballs and build this layered file system and then scan it. What we have is a gzipped 20 gig hard drive or a 40 gig hard drive and things like that. So it wouldn't really work in that way. But that kind of got me thinking, and I had a little bit of conversation with Liz Rice, who was at Aqua Security. So out of the box, Harbor supports a tool called Claire, which does image scanning, but based upon looking like an image. Aqua Security have a tool called Trivy, which supports being able to look at a file system. So the way that we could make this work is we could build a new image in Crocodile, and then we could, with a few steps, use Trivy to actually scan that. So what we now start to build up is the capability of hopefully signing images, but being able to scan them and basically say, this image is no longer secure, perhaps remove it from the registry and things like that. And I did a couple of tests earlier today. We can mount a gzipped raw image. There's tooling to do that. it pipes a lot of stuff through the gzip algorithm and is intensely slow. So when you're trying to do file searches on a 20 gig image, and it's having to do all these crazy lookups, it's just not going to work. So the way that it would have to work is Crocodile would build an image, and in order to scan that, we would need to either not compress the image or gunzip the image, mount it somewhere, and then Trivy could actually scan the contents of it, which is a little bit of a manual process, but it would work. It would allow us to scan images. But then I got thinking, maybe there's a way we can automate all of this. And what we can do is somewhere in here. There's a webhooks thing somewhere. Oh, there we go. So what we can do is on push. So this one here, blah, blah, blah. We can effectively tell a small service that I was affectionately going to name Wendy, but people may have better names for it. But effectively what this will do is we can push an image to Harbor. We can then get that image, we can decompress it, we can run Trivy against it to determine whether there are any issues with it. If there are, we can basically loop back to Harbor and say no one can download this until it's fixed. We're starting to get to the point almost where we can behave like you would do with Docker images and start to really improve security around all of this. So that's my kind of 1,000-yard idea about how we can get all of this extra cool functionality that people have been kind of doing with Docker images for a little while now. Are there any questions about that?
One small comment, which is often when you build and push an artifact, it seems secure based on your current scanning abilities, but a month later, a vulnerability is discovered, and then a rescan would discover this new vulnerability.
Yes.
So it would also be interesting to figure out how we could either rescan on an interval to make sure that these images are still secure, still seem
absolutely. Yeah, so I mean, we could just have a cron job, which basically grabs everything from the OS images registry, rescans it all, and blocks what's no longer allowed. Sends an email alert to whoever the OS image build team is for wherever you're running Tinkerbell to go fix your Ubuntu 1604 or whatever, and things like that. Cool. Okay, that's it for me. Thank you very much.
I have one question about the image scanning. Have you taken a look at Seraph? Seraph is a trying to figure out exactly how to explain it. It's basically like a static analysis. It means static analysis results interchange format. And now you just got me wondering. I knew of a company that was doing something like this using Seraph, and I know GitHub is using Seraph.
Okay.
I may ping you about that. I may ping you about that.
As I say, this is maybe almost flights of fancy. I have had it partially working today. I've only played with it this morning, but it did look as though we could actually really start to almost kind of get some level of enterprise level functionality around all of this in terms of the image promotion process, the way that we could actually scan these raw images, and just basically being able to take all of that free awesome registry functionality seems like just an obvious win, really. Cool. Next on the list is Mark. Oh, let me share my screen. Sorry. Oh well, unless Mark is sharing his screen. Marky, the special interest group creation.
Yeah, so we kind of a few of us were just having a random conversation, and we started talking about the formation of special interest groups, and what I wanted to do was sort of put that out there to the community, let everyone know that there were just some discussions, and see if anybody had ideas around that, and wanted to make sure we were I was at least transparent in the conversation that was had about special interest group creation for the Tinkerbell project. And really what I wanted to just sort of I don't want to say go on record, but just put it out there that that idea is being floated around. And one of the things that I was thinking about, in terms of special interest groups was, like contributor experience, SIG, and sort of really start to refine what, we're doing and as a project. And I was just wanting to see if anybody had anything. Not a lot of new faces here, so I think most everybody kind of knows that I've had this conversation, and I just really kind of wanted to put it out there. That was it, and if anybody wants to discuss, please do so.
Yeah, I'll echo Marky. I think it'd be beneficial to form some groups to help with things like governance and contributor experience. I think those are some things that could be really beneficial to the project.
I was thinking about opening a discussion in the Tinkerbell repo, probably in Tink, and start a discussion there, and then I'll send it out to the mailing list so everybody kind of knows that this discussion is taking place. And I'll do that today if everybody is, +1 for that.
Yeah, definitely.
Awesome. That was it for that subject. I think I have the next one as well.
You do. Discussable. To discuss a pluggable, been a long day. Discuss pluggable framework for Hook.
So yeah, and we can, one of those plugins we could probably put in there could be a discussable plugin. Joking. So I got to thinking about Hook, and I've been playing around and doing a lot with Hook in my spare time, and I really find a lot of benefit to that. One of the things that I have started to see sort of a need for is a pluggable framework, right? So one of the things that I thought of, like, that's, it would be awesome is I think of a pluggable framework like wanting to incorporate certain things, like, let's just say Slack, right? And you provision a machine and you have an automated message go through Slack. Now we could obviously set that up in certain ways, but wouldn't it be neat if Hook had that pluggable framework to be able to put these sort of channels in? And then when I started to think about that, I was like, oh wow, that's kind of a really big that's a big thing, because there's so many other ways that could go, and making this sort of, then I started to come up with framework, and I kind of started to think about all the different things we could plug in. Like, it would be awesome. You plug in, we plug in Crocodile, and we plug in the image scanning, and all of these things become a pluggable sort of mannerism to Hook. And what I really wanted to do was just sort of put that out there, that I was thinking about it, and that I'm going to be putting forth at some point this week a proposal on what the sort of clouds are in my brain thinking about, and kind of getting the community's feedback. And I just kind of wanted to think if anybody had any suggestions. I'll also start a discussion. I really like discussions. I think somebody raised their hand, and I new with the raising the hand thing. I really didn't know that existed. Dan, did you have a question?
Yeah, sure. So Gianluca has also raised his hand. I was actually going to mention that he's done some stuff around this. One of the things that I've been looking at, so one of the core concepts behind Hook was, to a certain degree, keeping it as small as possible. That is bad timing. Someone's at my door. I'm going to circle back. Sorry, I need to go to the door.
Okay, cool. Gianluca, what were you going to say?
Yeah, hi. I think that we have to figure out how many nested plugin system we want first, because the idea, like, Hook is made by LinuxKit, that is a pluggable way to build Linux distros. So, for example, I build my own one starting from Hook that does more things that are related to my way of provisioning servers. So, for example, I use console for DNS. So my Hook starts a console agent and registers itself to console, so I can visually see when a node is in hookable state, because I can, yeah, because I can see that registered to a console, or I had the Telegraph that is an agent that does monitoring. So I can see the stats coming from the services running in Hook, like Docker and memory and whatever. I had the teleport, so I can see, I can SSH into it. So really, like, Hook is just a YAML that runs containers. And containers, I see containers as a plugin already. So if you need something more,
Put another
add yours.
container. Agreed. I think Jason put in chat more kind of what I was thinking, not so much Hook, but more plugins for workflows. And I kind of butchered that, so I apologize. But that's more kind of what I mean, was a starting to design a pluggable architecture for workflows.
Okay. I mean, workflows are collection of containers. So what do you see as a plugin for a workflow?
Well, what I see is we create a bunch of YAMLs, which I don't know if that's necessarily good for a pluggable framework. Right? Because I mean, I guess the way I see it is, if I took the simple use case of Slack, and that means I've got to create a whole YAML and incorporate that as a workflow, which I don't know, doesn't seem right.
So what
when I think of a plugin or a plugin framework, I think of something that there is some templatized way, not in YAML, that I can put some type of a channel of communication or connect with another third-party service, but not having to build that through a YAML. Having a bunch of YAMLs, scattered all about, I don't know, it just doesn't seem right.
Is the event system for Kubernetes a good example for a plugin system?
I think that's one good example. Yeah.
So we deprecated our event system because it was made in a wrong way. So if we see that we need to do it again, we can. But that's an event system, I suppose. But yeah, I'm done. My hand is not raised anymore because it's not Hook related. So yeah.
Oh, okay.
Your hand is still raised.
I don't know how
it's
to
down.
raise my hands, but yeah.
And Jason can't even raise his hand. He's trying, but he can't. But Jason, what were you going to say?
Yeah, so the Linux UI is a little finicky with Slack or with the Zoom, and because I'm a co-host, I can't actually raise my hand. Anyway, what I was saying is the first thing that kind of triggered in my mind when you were talking about this, Marky, was like the ability right now, like if you want something to happen on every workflow, you have to define it in every single template right now.
Right.
And I could see some value in being able to say, like, I want to be able to run this action at the end of every workflow, and just a way to kind of compose some of the stuff that way. I think there's probably some power in that.
Agreed. Strong +1.
Is there is the model here to have extend tink, right, so that we can kind of define global pre and post templates, or sorry, tasks, right? Because we can have multiple tasks in a workflow, and if we've got things running at, if we have kind of hooks where we can kind of run things at a set point in time, then we can kind of still continue to use like tasks and actions and like those kind of muscle things that we're building up.
I think that is, but what I more want to do is wrap that a framework where we're standardizing on how global things, not just a task like Jason was saying, like I got to go put those in every single workflow, but a way that I can globally define what I want to do. And usually in most things that I've had involvement in, that requires some type of pluggable framework. A good example of something that I've dealt with from a different community would be Spinnaker, and building a pluggable framework for which different things could be used in there. Like if I want to integrate Jenkins with that, and I'm just using this as sort of the example, but you have to have a pluggable framework rather than having everybody go through and create a whole series of different steps in a given YAML. I don't know, it just seems hokey. Dan,
Sounds like
They keep saying pending.
Yeah, I think
raise it, Dan, raise the hand.
I think like revisiting the event system might kind of be one of the things that you might want to look at to see if it fits your need. What I'm hesitant about is like adding a third kind of execution mechanism or like a third entry point like into the whole system, right? You know, tasks and actions and workflows are kind of the direct way to kind of do things. And then the idea of like the event system was to kind of be able to, on the periphery, kind of introspect and see things going and kind of do things on the side. And either we kind of, I don't want to get rid of that concept in general and completely, or kind of maybe revisit it and kind of extend it better. Yeah, I know they're deprecated. But I think like the idea in the conversation, I think they're deprecated in the way it was implemented, Gianluca, right? I think we all kind of thought it was nice and there was good reasons for it, and that it just came in early, right? And so, you know, we had planned to revisit at some point, right? I think it might be, you know, a good time, or maybe with Marky's kind of use case in mind, you know, having that thought might kind of be helpful, or it might just be a separate kind of way to go, and we can kind of just get rid of the event system in general the way it is now, or the way it was.
Yeah, so I will take a look at the event system. I was completely unaware of that. I'll take a look at that today. Dan, I want to hear what you have to say.
I've got a myriad of thoughts now. There's a bunch of kind of cool ways that we could kind of go about implementing this, I suppose. We looked at long running tasks, effectively. So an action that would run for the life of the workflow. We could have that as something that is inherited by all things that are provisioned. And effectively, one of those long running tasks could well be have a small called service. Okay. Well, apparently a long running task that could effectively open some level of socket or something or other, which would allow a action upon completion or during or whatever to generate events and pass that through to one of these long running services, which will then fire it into whatever system it needs to go into, whether that's back to Tink Worker or directly to some level of notification service. I don't know. I'm just thinking off the top of my head. It's probably best we just kind of go down the proposals process, because I imagine it sounds like everybody's got a million fantastic ideas, and we're going to take some time to distill all of this.
I'm really thankful for everybody actually giving feedback on that. I do want to highlight one of the things that Gianluca said in the chat, and this is for the recording that people may not be able to see, that is plugins are the secrets of success because you can outsource whatever you don't care about much. Helps with maintainable software. I think that if we look from a high 30,000 foot view of what a pluggable framework is trying to achieve, that would be like the mission statement right there. Mm-hmm. That really encapsulates what we want of this type of a framework. What I foresee is when you build a framework for whatever it is, service, whatever you want to call it, and you make it easy to use, you will really increase, I think, a lot of users wanting to, oh, this is easy to do. I'll contribute to this project because I can write it for, enter in your channel or service that you want to incorporate, third-party service, because it's now, you've done it in such a way. And I think that has a lot of value for this project. But I will move it to the proposal route. And I thank you for giving me the time to ramble about that.
Awesome. I've lost my window. Oh, here we go. I believe it's Marky again.
Oh, look at me. I think during our last meeting, we talked about moving this meeting up an hour.
Mhm.
I will say that for the West Coast folks, I'm barely finishing the first cup of coffee at this time. So I would like to ask the community if you would be willing to move this meeting. It's 7:00 a.m. my time when this meeting starts. If we could move it to 8:00, that would really be. I won't have to stumble downstairs and trip over things. And,
Yeah.
oh, Gianluca said yes, even 9. Don't threaten me with a good time. If I'm not the actual leader of this meeting, so I can only propose it, and if everybody's cool with it, then either Gianluca or Dan can actually action that. But if everybody was cool, I would be awesome. Would be very thankful.
Yeah, +1 for later times.
Thank you, Gianluca. Really appreciate that. That was all from me.
Excellent. Thank you so much for that. And yeah, good discussion around where we're going to go with Hook. Next is Nahum.
Yeah, so the note I put in there is metadata and using Hagel with Cloud and disk image-based provisioning. So I've been playing with, and I opened a pull request. I've been playing with the sandbox on Equinix Metal, where I have the 2 bare metal machines, and I was able to provision the Crocodile-based Ubuntu image to the worker node, and that works great. The step I'm at now in terms of eyeing this towards how I would put all of these things into production is getting metadata into place. And I think historically there have been a few different options. In the past, I think there have been templates and workflows where we had old ones that would drop a kernel and a root file system onto a machine and then add additional files into the file system. But it looks like there may be some use cases where we already support Cloud in it, and Hagel looks like it has most of the right metadata support that we need. But I'd love to get us to the point where there's a very clear demo of, we take this image that came from some sort of upstream vendor. Probably the easiest one is like the Ubuntu official image, which I assume sort of out of the box expects to be able to do Cloud in it in a way that's compatible with things like EC2, and demonstrate, aha, we've provisioned it to the machine, and then it woke up and it talked to the Tinkerbell stack, to Hagel, and it did all the right things. It set the host name, changed its IP configuration, all that sort of thing. So we definitely have most of the pieces we need. I guess I'm asking, like, has anyone already done this and we can just improve the documentation to that point? Or are there, and there's Gianluca says this is what Kept does. So I'm going to stop talking and let people who know things now jump in.
Yeah, so I can say what I've been doing with the cluster API stuff is mostly manual configuration right now after standing up the sandbox. And that was mostly because I wasn't sure how much support for the particular like link local configuration that I was doing there would work outside of a local libvirt environment. If we deployed this on Equinix Metal, would we hit issues with hosts being on different tops of rack switches and not being able to talk on that link local address, things like that. And I think it takes a little, it's going to take a little bit more kind of figuring out, how do we do that? I think there's the shorter term approach where injecting the configuration is probably fine. Longer term, I think we have a few different options, and that's, the first option is either just conform as much as we can by default to what AWS does today, use the same link local address, use the same metadata conventions, things like that. The other long-term approach is actually make some changes in Cloud Init to add support for Hegel proper as a data source, proper detection. How do we detect if we're running within Tinkerbell or an environment that's using Hegel, things like that. And I think that's probably the better long-term solution because then we can make whatever conventions we decide we want to go through for Tinkerbell, make those available upstream in the same way and detect it and use it, and not have to worry as much about trying to piggyback on top of the EC2 metadata support, that type of thing.
Just so I understand that, with that being the much longer term play of, we get our data source integrated into cloud in it, and eventually upstream vendors start deploying their building images with the latest cloud in it, and then suddenly the Tinkerbell / Haggle support would be in there.
Okay. Yeah, and there's potentially, it's definitely long term. You have certain OSs like the Rails and other long term support distributions. It may involve trying to backport to certain older versions and things like that for support. But I think longer term, that gives us the best way to have, a way to sit there and do this where it's not, specifically dependent on like that link local address working correctly and things like that. We can have a convention that is a little bit more universally supportable.
And for that, it's just figuring out. Oh, go ahead.
Sorry, apology, a dumb question. Is the link local stuff you're talking about, is that part of the EC2 spec for like their metadata?
So it's part of the way that they default configure their metadata. So like the EC2 metadata service, if it detects it's using EC2, which it does that in a few different ways with the data source provider, it'll reach out to a specific link local address by default unless you override it.
Oh, okay. So it's the discovery mechanism for EC2 metadata, not necessarily like the spec itself.
Yeah, and it's also some that's replicated in other places as well, basically because AWS started the convention.
Got it. Cool, thank you.
One other piece I'd like to add in there is that the way that Cloud Init at least bootstraps itself is it detects what kind of cloud environment it's in. And usually it looks to DMI for that. So it's looking for some DMI tag that says, I am running on EC2, I'm running on DigitalOcean or whatever. And that's a challenge in Tinkerbell because the hardware isn't stamped the same way. So we might have to come up with more creative ways for Cloud Init to detect our hardware. Our hardware meaning something that's been deployed in a Tinkerbell environment.
Well, we control the Bootstrap environment, right? Wouldn't that just be a nice little improvement to Hook or Aussie?
So that's the sort of one of the other alternatives. So one of so side note, if you look in that pull request that I opened on that documentation, one of the things I ran into is some pieces of hardware put their serial over LAN port on a different port than what most cloud images expect. So you have to start, there is probably some degree of tweaking that people running bare metal will have to do to images that they deploy. And the question is sort of, in my mind, is how much of that should we, where should we tweak Tinkerbell to avoid tinkering with and messing with the images that come from vendors? And where should we just say, because of the specifics of deploying images to bare metal, we are going to expect to have to make these changes. And I guess I'm also open to saying like, oh, what we should do is have that we should expect to have an action where we tweak the Cloud Init config at provisioning time. So we'll tweak how it's which serial port to use and tweak how it's going to talk to Cloud Init. And like, I guess I actually did a full write-up internally of some other, like I have concerns about BIOS versus UEFI and like how that's going to play out and like 512 native versus 4K block hard drives. Like as you're dealing with real machines, there's all sorts of interesting like edge cases that start coming up. But yeah, so I'm not sure exactly where the balance lies, but I figured it was a good conversation to have with everybody. Manny
Cool.
says he prefers to
Yeah.
mess with grub and proc command.
Yeah, I think that you bring up a point with like the serial port, right? If we're waiting until we've booted up and CloudInit has able to parse whatever and figured out that it needs to mess with serial port, right? Then it's already too late, right? We've already missed a bunch of kernel stuff, and debugging those early failures are going to be no-goes. So it kind of seems that just kind of early on messing with the grub or just like the bootloader config, it might be kind of where we can most easily and like best bang for buck can do these tweaks, right? And just kind of do some of the tweaks like serial port and tell CloudInit that we're running on Tinkerbell stack and kind of get our foot in the door through there.
That's an interesting idea. I guess the tricky thing there is like that's great for all the Linux distros, but there's still like Windows and VMware out there, and those are going to present their own challenges as well that I'm slightly less familiar with.
And one of the other things that I wanted to mention on this topic as well is if we do go the route for CloudInit, and this is distinct from like the serial port configuration and all of that stuff. The one of the big benefits we'd have with going with a custom CloudInit data source would be then we would have the ability to actually parse the JSON-based metadata that's exposed via Hegel rather than having to use the EC2 compatible metadata source. And that would give us a little bit more flexibility in how we access the metadata that's presented and actually use it rather than trying to conform everything into, that EC2 compatible metadata.
I like to add I think this is a good conversation because I've heard rumblings that some rumblings about whether Hegel was actually useful or not. So it sounds like it is useful and not something that should go away anytime soon, which would be helpful when we start to develop maybe some SIGs and governance to really define like the purpose and where Hegel fits into the picture so that it can be, not that it's not a first-class citizen now, but become a proper kind of first-class citizen in the project.
Yeah, I think the biggest problem that we've had around Hegel is that there's zero documentation around it. So kind of knowing how to use it is anybody's guess. So like if we can start to improve the documentation around it so people know how if they want to write their own parser that they have a unit file for or whatever they want to do. Yeah.
So with regards to Hegel, I'm actually going to today start doing some work on it because the main package needs to be really split up into smaller packages. It's quite large. So I will actually take an action item myself to start to draft some ugly documentation and we can fix it from there. But I will actually take an action item to do that. I'll open an issue so we can track it.
Excellent. Thank you very much. Yeah, we need a start basically. I think we've unfortunately not got anything to go on at this point.
Awesome.
Thank you.
Someone linked a couple of GitHub issues, both for Hegel and CloudInit in the chat. And I was wondering if just some explanation is available.
Yeah, I linked them. I've been interested in getting CloudInit support for Equinix Metal hardware. The hardware is varied. Some of it has that DMI message block that identifies the machine as Equinix Metal or packet, and some don't. And so that was one of the challenges I found to getting this PR added that would teach CloudInit how to detect an Equinix Metal or packet host device and then kick that over to using the metadata service that packet comes with, which is a DNS name, metadata.packet.net or Equinix platform something.
Which would contain, amongst other information, which provider, specifically for this purpose. I'm curious. It's been like literally years. I haven't looked at this, whether that ever went anywhere. That doesn't help with wanting to be able to use like upstream images and kind of not necessarily need to transform them, right? Because like what otherwise we can, if we can just do what we're doing today now, right? In Equinix Metal, we can just drop like the data source configuration. Right. We would just be dropping that one file, defining it. Yeah, that's the only thing. Obviously, yeah, you still have to deal with it. I don't know that there was any way to get around that. Obviously, all the hardware was tagged in some fashion, DMI data, but I don't know that that could ever be relied upon either.
Yeah. Go ahead, Marcus.
Yes, I'll just continue, I think, where I dropped off. So well-known data sources, we don't know that in an environment like an environment somebody's running in Tinkerbell, where there could be lots of different hardware models, and each piece has the specific piece of DMI written at a different key in DMI. So the proc command line approach that that Manny mentioned, that seems like maybe a way around this. And so I noted on that cloud init issue that closed due to just timing out. I'm asking SMOs are there if that might be an approach we could take.
Just to make sure I understand what you're saying that if we explicitly decided that we would reveal ourselves to the image by tweaking prop command the kernel command line, then that would be the one change we would have to make. And we would basically, as Manny said, just change things regarding booting. So grub's config and whatever grub is passing to the kernel command line to then make sure that the Linux kernel will behave correctly on our hardware and that it'll pass the right information to cloud init so that cloud init can just be off and running.
Yeah, exactly. When cloud init runs inside of the operating system, the first step it takes is to investigate the hardware it's on, and maybe we can also have it just check these kernel flags, this command line argument, and make its decision based on that. After that, it expects that based on knowing where it is, it should know where to find the metadata, and then it acts accordingly. It runs the user data, it configures the networking, the SSH, et cetera, et cetera.
And I guess the one question there is, the remaining question I have there is, it's one thing to have an Equinix Metal data source. It's something different to have a Tinkerbell data source. And like I'd rather build something that is reusable in Tinkerbell that doesn't depend on a specific Equinix Metal host name being the default place for that it checks. I'm not sure how to do that, but that is a value that I think we have.
Yeah, exactly. So if we Equinix Metal, and the ancestry here is the Hegel service, and having Equinix Metal specific provider is something that on a cloud init PR is maybe quicker to get across, because we can take advantage of DMI. We can try to make sure that all the hardware has this Equinix Metal written to it somewhere. But that's definitely not the case for Tinkerbell. And I think we should see if we can look at the command line parsing as a way to accomplish this for both environments. It does create a problem for like Windows, but I don't know if Windows is using CloudNet.
Cloud Basin it, which is same exact concept, completely different implementation.
And we're also going to see similar things when we start talking about outside of cloud init and things like Ignition for Flatcar and other systems that use the available user data in different ways than just cloud init.
All right, excellent. Well, we'll come to the top of the hour. Is there anything anybody else wishes to bring up? Or any next steps on I know Marky's raised an issue around starting to document Heagle. I think that's probably going to be a good first approach anyway, for us to then work out where we can take it kind of next.
Yeah, I'll be putting that documentation on the front burner.
All right, excellent. Okay, well, cool. Thank you very much, everybody, for joining the Tinkerbell community call. A lot of fantastic discussion this week, and I will see you all on the community Slack and again in a couple of weeks' time. Have a great day, everybody. Thank you very much. Bye.